So if you have a galvanic cell, it is due to the spontaneous reaction of a given system. So the spontaneous reaction produces energy. Okay? So yun yung what we call one contributions of electrochemistry to mankind in the form of a battery. So let's try to solve problems. So as I told you, this is how they are related. Okay? So let's try to solve problems here. Now, what do we know about getting this so-called oxidation half reaction and redox half reaction? In the previous class that we have, we said that if we have a galvanic cell or a voltaic cell, the one that is reduced is the one that has the higher reduction potential. And the one that is oxidized is the one that is going to reduce, to be what we call the one that is oxidized is the one that has a lower reduction potential. Now, that statement is only true if you have a voltaic cell. Now, sometimes you don't know if the system that you have is a voltaic cell or an electrolytic cell. So how are you going to identify, let's say if you're given this reaction, which one is oxidized and which one is reduced? Okay? So in cases where a reaction is given, all you need to do is look at the species that undergo oxidation and undergo reduction. So you can ignore the reduction potential of each of these species because the given reaction takes precedence compared to the value of your reduction potential. Because the one that we learned before, the one that has a higher reduction potential, that's the one that's always reduced. And the one that has a lower reduction potential, that's the one that's always oxidized. But that's only true if you have a voltaic cell or galvanic cell. And remember, not all electrochemical cells are voltaic cells. Now, in the given reaction here, which do you think is oxidized? Tin or copper 2+ or copper? Anyone?
Or yung tin.
Okay. So if we're going to look at here, we could say tin is from 0 going to +2, while copper is +2 going to 0. So the one that is oxidized is tin. So you can always put the reaction here as like this. And then the one that is reduced here would be the copper. Kulang eh. Copper, ano ba yan? 2+ plus 1 electron producing copper plus. And then we just balance it because there's 2 electrons involved in the exchange. Okay? So in that case, if we're going to look at the cell potential here, we're going to go with what? The cell potential of the cathode minus the cell potential of the anode. So ibig sabihin, we need the reduction potential table to see, okay, what's the reduction potential of this? And what's the reduction potential of this? So I can always list that to you. So make sure maybe in your quiz for this module, you have a reduction potential table. Okay. So if we're going to have this, what we call information here, So all you need to do is have a reduction potential. I'm trying to find my own reduction potential table. Okay, so I cannot find it. I have to go back. Tin and copper. So if I have it here, tin. So this is the one. And the copper that we have is this one. So we have a negative 0.14 and a 0.16. So this is what? Negative 0.14 and this is 0.16. Tama ba? So based on the reaction here, the way that you're going to identify which one is the cathode and which was in the anode is based on the reaction that you have, not based on the value that you have here. Okay, so it may be a coincidence that the copper has a higher value than the tin, but the one that dictates us which is the cathode and which is the anode is the given reaction. Klaro ba tayo doon? Na kapag may given reaction, i-determine mo based sa given reaction, alin yung na-oxidize, alin yung na-reduce. Okay? So, we're going to do it here. So we could say what? 0.16 minus negative 0.14. And what do you get? Is it 0.30? But as you could see, we're not only asked for the cell potential. What we ask is the equilibrium constant. So how are we going to solve this? Maybe we can go back to the previous slide and then get what? This one? Because we have just calculated this one and we're going to calculate for the K. Okay? So I can use there E cell equals to, is that 0.0257 divided by N ln of K. And then I can isolate this on one side. So I will have, how do we do it? N E cell divided by 0.0257 equals to ln of K. So ano yung N? What's the value of N? Anyone? Anyone who wants to answer? Ano yung value natin ng N?
3 po ba, sir?
Is it 3? Where do we get N? N is the number of moles of electron. So how many electrons are involved here? We have 2 electrons. So we could say 2 times 0.30 divided by 0.0257. Now, before we answer the question, do you have any idea what will be the value of K? Will it be more than 1, less than 1, or equal to 1? Anyone?
Less than.
Okay. Now, you may ask yourself, paano natin malalaman yun, sir? Because you're given already here the value of E cell. So remember, This is the relationship that we have. So what's the value of the E cell that we have there? It's a positive value. So if it's a positive value, your K will be more than 1. Is that clear?
Yes, sir.
Sir.
Yeah, question. Any question? So based on the value of our cell potential, which is positive, we can say that, oh, our K will be more than 1. So let's see. So what's the value when we did the operation here? So 2 times 0.30 divided by 0.0257. So I get what? A 23? 23.35. So how do I eliminate ln? So K is just equals to, is ln 10 or E of 23.35? So what do you get? I get around 1.4
1 point. Yes, sir. Times 10 raised to 10.
to the 10. Or 1.37 or 38 times 10 to the 10. So what does this value means? It confirms our prediction that the K is more than 1. You might have a calculation like this, or you might just ask for the relationship of this thing. So remember, what we're doing here is just a supplement on the course pack. Okay? So this is just additional, we could say, session to make sure that some concept that you're not able to understand will hopefully be covered by this supplemental value, what we call session that we have. So question, before we go to another problem.
Sir,
Yep.
paano po malalaman katulad nung last time na yung 0 po yung sa may cathode? Ganun.
Paano malalaman kung 0?
I mean, yung gagamitin yung 0, di ba, sir, katulad nung
When you
last
have
na,
a hydrogen, an SHE, a standard hydrogen electrode. So all you need to do is look at the reduction potential table. And there's only one species that has that value of 0, which is this one.
okay po, sa clarification, sir. Medyo nalilito ako kanina. Okay po.
Okay. So let's try another one para lalo niyo maintindihan. So ito naman. So you are going to calculate what is free energy here. That's your delta G. But before you're going to calculate for delta G, okay, you have to calculate for the cell. Now, as I have told you, if the reaction is given, you have to base, okay, what species is oxidized or what species is reduced based on the given reaction. So yung OHR, dyan nangyari yung anode. Yung RHR, reduction half reaction, that's the cathode. So between the two species, gold and calcium, which one is oxidized?
Gold, sir.
Gold.
Gold po.
Okay, very good. At least at this time, you'll be able to identify which one is oxidized and which one is reduced. Because you might have a question like, given this equation, which of the following is oxidized, which of the following is reduced. Yun yung mga easy question na dapat sure na. And if gold is the one that is oxidized, you can assume that the calcium is the one that is being reduced. Okay? Now, you still need to add here how many electrons kasi yun yung magiging value ninyo, ng N ninyo. So here you could say that's a 3 plus, so you can expect there's a 3 electrons here. Now, if there's a 3 electrons here, what will happen? Okay? So ito a 2 plus, ibig sabihin meron dalawang electron dito. Right? But if you're going to look at this, is the exchange of electron the same? Pareho ba yung exchange of electron nila? The answer is no. One is 3, the other one is 2. So you have to balance the exchange of the electron. So the best way to do is to exchange them and multiply. So kung ano man yung number nito, i-multiply mo ito ng number na nandito. Kung ano man yung number na to, i-multiply mo lahat ng equation ng number na ito. So that means this becomes what? 6, 2, 2. And this becomes 3, 6, 3. Let me know if you got it. So ano ngayon yung N? Value. Anyone?
6 po.
6. So the N value is the number of electrons that are what we call participating in the balance equation. Okay, tandaan nyo yun. Now, the next thing that we're going to do, okay, so we have to get the half reaction or the reduction potential of the reaction that we have. Let's say for this and for this. So we need a table. Gold 3 plus. Dito ba ang gold? Gold, always revealing your soul. You got what I want to know. I think we can look at here. So there's the gold, 150. And the other one is calcium. Where is calcium? Here. 287. So this is what? 1.50 and this is negative 287. And the first thing that we do is to get the cell potential. So paano natin ilalagay yung mga value? Ano yung anong value yung nasa anode? Ano yung value na nasa cathode?
Negative 287 minus 1.50.
Everyone agree on that? Because pwede nyo sabihin na, sir, di po ba sabi nyo dapat malaki lagi yung cathode kaysa sa anode? When that statement is true, that the value of the reduction potential is cathode is always larger than the value of the reduction potential in the anode. If you only have a voltaic cell. But here, you may ask, paano napunta yung negative 2.87 sa cathode? Di po ba sabi nyo, kapag kino-compare natin yung reduction potential, yung yung cathode ay usually mataas kaysa sa anode. But that's always true if it's a voltaic cell. Now here, we base the anode and the cathode based on the given reaction. Nag-gets nyo ba yung ibig kong sabihin? So in this case, if you're going to do the calculation, what do you get? You get a negative value. You get what?
4.37.
4.37. And it can tell you that it's not a voltaic cell. So if that's the value that we have, because the next thing that we're going to do is get the delta G. So which are we going to use the equation for the delta G? So we could say delta G is equals to the value that we have here. So that's the N, the Faraday constant, and the cell potential. And if you're going to look at this, that's a negative NFE cell. So if you have a negative E cell, you're going to have a positive delta G. So ano yung value ng delta G natin dito if we predict it? That's going to be a positive delta G. So that means the reaction is not spontaneous. So ano yung mga value na ilalagay natin dito? NFE cell. You put the 6. You can always use the 96,500 joules per volt. And then you can use the negative 0.37 volts. And if you have that, the volts will be gone. And what you have is a unit in joules. So negative 6 times 96,500 times negative 4.37. So what do you get? So I have this value 1, 2, 3, 4, 5, 6. There's a joules per volt moles. So this is what you get. Analyze.
Saan po nakuha yung ano,
Alin?
1,500?
Yun yung Faraday constant, yung F. If you're going to go back here.
Sir, may table yan, sir.
I'm not sure kung may table yan. Pero it's a constant. Ito.
Constant.
Yan. Ito yung value. Ito yung ano niya. Ang tawag dyan ay yung Faraday constant.
Okay, sir. Thank you po.
It's the charge of 1 mole of electron. Usually yung definition yan. Yung Faraday constant. Okay? Now, question. Before we go to Nern's equation. So far, what we have discussed is in standard condition. Now, what if we have a non-standard condition? So when we say non-standard condition, the concentration is other than 1 molar. Okay. The temperature might be other than 298. The pressure is under 1 atmosphere. But if we're just going to look at non-standard state, the most common one is if we have a concentration that is different than the standard concentration, which is 1 molar. So ano mangyayari dito? So that happens when your free energy is a non-standard state. Wala tong degree sign. And if that's the case, you have to consider what we call the Q. Ano ba yung Q? That's just the ratio of the product over the reactant that is not in equilibrium at any time except in equilibrium. So kapag break down mo yun, so delta G is still equals to negative NFE, and then standard delta G, that's still equals to negative NFE. So see the difference here? Is the presence of the degree sign here. So here you could say it's not 1 atmosphere. The concentration that you have here is 1 molar. Here, the concentration is not equals to 1 molar. So anong ibig sabihin nito? Pwedeng mabago yung cell potential kapag iba yung concentration ng species mo sa given cell. Okay? So if we're going to substitute the delta G and the standard delta G, you will have it like that. And then you can divide all of them, okay, with NF. So if you divide them with NF, maka-cancel yung NF doon. And this is what you get. You divide it, I forgot to say it's a negative NF, okay? That's why you have a negative there. So ibig sabihin, everything depends on what? At the standard temperature, you can have this value divided by N. So everything depends on the Q, which is your ratio of the product over the reactant. So anong ibig sabihin nito? Kapag nabago yung concentration mo sa given cell, pwedeng mabago yung cell potential mo. Let's try. Let's try this problem here. Predict whether the following reaction would proceed spontaneously as written at 298 Kelvin. Given that the cobalt concentration is 0.15 and the Fe2 plus concentration is 0.16. So anong gagawin natin dyan? Maybe the first thing that we do, okay, let's try to get the standard E cell. So that's just a cathode minus an anode. So let's say if I have the reduction potential of Fe2 plus with Fe, and then the reduction potential of cobalt 2 plus and cobalt. So let's say I put the value here, okay? This one, Fe2 plus, that's a negative 0.44 volts, while the cobalt is negative 0.28. So ang tanong ko ngayon, alin yung cathode, alin yung anode? Because kukunin muna natin yung standard E cell. So based on the given reaction, which species in the anode and which species in the cathode? Anyone?
Cobalt po yung nasa anode.
Okay? So yung cobalt, I'm going to put it at here. Tapos ito. Now yung iba, na-follow nyo ba? Bakit yan yung sagot? Kasi kikita mo yung cobalt dito, from 0 oxidation number, naging +2. So siya yung na-oxidize. So siya yung nasa anode. Now yung Fe2+, naging Fe. So from +2, naging 0. So siya yung na-reduce. Now, the one that we solve here is just the standard cell potential. And that is equals to what? Based on the number here. Anyone? So this is what I got. Now the next question that I'm going to ask you, will this reaction happen spontaneously at standard concentration? Ano yung sagot nyo? So maybe mag-survey tayo. Kaya ko bang gumawa ng poll? Tingnan ko up. Nope, lalabas ako. Will take time. Pwede pala. Para at least makaparticipate kayo. Kasi nga, will this reaction be spontaneous at standard condition or standard concentration? So tingnan natin ilan yung gising or ilan yung nakikinig. So dalawa lang out of 7 ang mulat. Okay? So 2 out of 3. So will this reaction be spontaneous? The answer is, look at the value. It's a negative sign. So at standard condition or standard concentration, it's non-spontaneous. Now, ang tanong ngayon, paano pag binago natin yung concentration to 0.15 and 0.68? Magiging spontaneous pa yung reaction. So, dito papasok yung Nernst equation. So, ang tanong ko dyan, ano yung N? So, yung E dito pwede yung 0.16, tapos 0.0257, tapos ano yung value ng N? Anyone wants to guess?
Two po. 2.
2. Usually kung ano yung charge dito, yun na yung N. If not, then you have to do the half reaction like this. Tapos yung isa ay Fe2 plus 2 electron producing Fe. So dyan yung makikita yung value ng N. Now, how about the Q? How are you going to represent Q? Ang quiz niyo simula bukas is about KEQ. So how are you going to represent Q here? You're going to look at the reaction and you're going to look at the concentration of this one. So, ano yun nandito? Fe2 plus or CO2 plus sa numerator?
CO2 plus, sir, kasi product po.
Okay, so CO2 plus because it's a product, and then you have here Fe2 plus. So you're going to put it, you're going to replace the value that's given there. So 0.15, and this one is 0.68. Now the question, if you're going to solve this whole problem, will you get a positive E? Kasi for the system to become spontaneous, the value of your cell potential should be positive, because at the standard cell potential, it is negative. So please solve. Ano yung number na nakukuha nyo pag ginawa nyo yung problem? Will it become spontaneous or it will remain non-spontaneous? Hmm?
Magiging positive.
Magiging positive ba? Ano yung value na makukuha natin dito? So we have ln 0.15 divided by 0.68. So I get a 1.5. Ito lang dito, ha? And then I multiply it with 0.257 or 0.0257 divided by 2. So I get here a 0.019. So what do you get? Negative 0.16 plus 0.019. So I get around negative 0.14. So it's still non-spontaneous. Analyze. Kung may tanong, huwag mahiya. Kung nalalabuan, let me know.
Sir?
Yep.
Question po.
Sure.
Sir, kasi nung ano po, yung 0.15 divide by 0.68, ang sa akin, sir, ay 0.22.
Yep, and then you get the ln.
Okay po.
You get the ln of that 0.22, makukuha mo yung negative 1.5. So, ibig sabihin
Okay
itong
po.
bilog na to, yan, sa buong ano yan. Equal.
Okay po. Sige. Nalito na, sir. Thank you po.
Okay lang. Now, you may ask yourself, kailan po magiging equal yung dalawa? When will this be happening? When your value of Q is equals to what?
Sir, kapag same po yung ano, kapag 1 po yung ln1 is equal to 0. So kapag equal po yung ano, concentration ng reactant sa ng product.
Yep. So when the reactant and the product concentrations are the same, your Q is equals to 1 and lnQ or ln1 is equals to 0. So kapag 0 to or ln1 to, automatic 0 na siya. So mawawala na yung expression dito or that expression will now become 0. And in that case, magiging pareho yung dalawa. So yan yung Nernst equation. So this ends the voltaic cell. Wala pa tayo doon sa electrolytic cell. So ano masasabi natin sa voltaic cell? The reaction is spontaneous. The system produces energy. The anode is where oxidation takes place. The cathode is where reduction takes place. Paano naman nagkakaiba yung tinatawag nating voltaic cell doon sa electrolytic cell? Because electrolytic cell is basically on electrolysis. So when you say an electrolytic cell, you have a system where the reaction can only happen if you apply energy or if you use energy. So electrolysis is the process in which electrical energy is used to cause a non-spontaneous chemical reaction to occur. Okay? So for instance, if you want to produce sodium metal and chlorine gas, you can use it from electrolyzing the molten NaCl. Okay? So what happened? So meron kang cathode at anode. And just like what you have in the voltaic cell, the cathode is where, okay, reduction takes place and the anode is where oxidation takes place. So if you're going to look at the reaction, if you have a mixture of NaCl, in the cathode, your Na plus will be converted to Na. And on the anode, your chloride will be oxidized to give you chlorine. So whether you have a voltaic cell or electrolytic cell, okay, the reduction always takes place in the cathode while the oxidation always takes place in the anode. Whether you have a voltaic cell or an electrolytic cell. Ang pagkakaiba lang yung dalawa, yung isa, you use energy, yung isa produce energy. So you need a source of energy, which in this case is a battery. And I think the most common example of electrolysis is water. What happened if you electrolyze water? You separate them to give you hydrogen and oxygen. So ito yung reaction na nangyayari dun. So it's still what we call a redox reaction. Okay? Now, I don't know if you have a news about a car being run by water. Have you heard that news before?
Yes, sir.
And what can you say about that? Is it possible?
Hindi po. Parang hindi po, sir. I mean, kung possible siya, sir, hindi po efficient. Or
so this is the thing. If you say water, that means it needs to produce energy. But as you could say, when you have water, you apply it with energy, you produce your H2 and O2, just like the one that we have here. Unless you can form a device wherein you put water and it will produce some amount of energy. That's the machine or the engine that you need if you want to have a water-powered vehicle. But as you can see, by convention, you usually use energy to electrolyze water. So that's where the science fails when somebody said, oh, I can run water as fuel on my car. If you can do that, I can tell you right away, a lot of people wants to kill you because you're going to kill the economy of some countries, okay, whose economy or income depends on what? Oil.
Fossil fuel.
Yeah. So if you said, oh, I can have a car that runs on water, I can tell you overnight, a lot of countries will go bankrupt. Okay? Because they depend on this, what we call oil that they have. So that's the thing. The science is against it. But it's still possible if you can have a device that you put water and it produces energy, then that's it. Okay? Now, how do we look at the problems, let's say, in electrolysis? So usually, as I have told you, electrolysis, you apply energy. And the form of energy that they have there is in the form of charge. Where do you get the charge? From a current that is applied at a certain time. So when you multiply current times time, it will give you the charge. And you can determine the number of moles because based on the Faraday constant, 1 mole of electrons is equivalent to 96,500 charge. So from that, you can determine how many moles of the substance that you have. You're just going to use the mole ratio in the hot reaction. So you can get the moles of the substance that is reduced or the moles of the substance that is oxidized. And then you can use the molar mass to determine the mass in grams or the ideal gas equation to determine the liters of the product. So let's try to solve. I'm not sure I want to use this. Papalitan ko lang to because I think in my PACE lecture, this is the problem that I use. But I want at least if you're going to watch that thing and this one, so you can have different example. So at least marami yung point of view ninyo. So I'm just trying to replace it with another problem that is different from the one that you have there in my lecture, recorded lecture. Teka lang ha. This is chapter 18, if I'm not mistaken. Nope. At least marami kayong set of example. So should be in 18. Madali lang naman to. I think this one. Oh no. Oh, mas mahirap to. I will just stick with this one. It's fine. Mas mahirap yung isang example eh. So we'll just stick with this one. So how much calcium will be produced if an electrolytic cell of molten calcium chloride if a current of 0.452 ampere is passed through the cell for 1.5 hours. So paano yung approach natin sa problem na ito? Okay? So we base it on this one. So first thing na natin, titignan natin kung...
Pero nag-share ka po ba ng screen?
Hindi ba nakashare? Sorry. Ay, oo nga, tatanggal ko. So it's the same problem that we have there. So maybe the thing that we can do is you have a molten calcium chloride. So ano yung nangyayari sa anode? Ano yung nangyayari sa cathode? So what will happen to the calcium chloride? It will generate what? It will generate a calcium 2 plus and
Ca2, Cl negative.
2Cl negative. Now the question is, alin dyan sa dalawang species ang mag-oxidize at alin dyan ang marireduce? So which do you think is the one that will oxidize? The calcium 2 plus or the chloride?
Yung Cl.
So you could say this one will what we call oxidize, giving you Cl2 and 2 electron. Yan yung pinaka-importanting part. You need to know which one is oxidized. You need to identify which one is reduced. And the other one, you have calcium 2 plus 2 electrodes to produce calcium. Now you might ask, do we need to do that, sir? What do I say? Yes, because you need to determine how many electrons are involved in the reaction. So if you're going to look at the overall reaction here, so you have what? Calcium 2 plus 2 chloride producing calcium and Cl2. Now the question now is, what is the one that is being asked? Calcium. So you have a calcium 2 plus and you are asked how much calcium is produced when you apply this current for this long time. So maybe you can start, okay, I have a 0.452 ampere, and then I multiply it with what? 1.5 hours, which I need to convert to second. Now, ampere is coulomb per second, so I can replace this and make it like that. Why? Because I need to cancel out the unit. So kapag tiningnan mo to, andito na tayo. Itong part dito. So the next thing that you're going to do, it says there, you divide it by the Faraday constant. So ibig sabihin, for every 1 mole of electrons, you have 96,500 coulomb, which you can now cancel because you have coulomb per second on the ampere. So here, nandito na tayo. So anong next na gagawin natin? Sabi doon sa guide, you're going to use the mole ratio of the half cell reaction. So alin half reaction na gagamitin natin dito? This one. So anong sabi doon? For every 2 moles of electron, we have how many moles of calcium?
1.
1 mole. We can end here wherein your unit is moles, but you can still continue with grams. So how are you going to convert the moles in grams? Because this one is canceled out. So you want, let's say in grams, so for every 1 mole of calcium, you have what grams of calcium? Is it 40 grams somewhere?
Yes, sir.
So if you're going to look at this, so you can now get the answer in grams, and that is equals to what? Ano? Pag ginawa nyo yung operation dito, 0.452 times 1.5 times 3600 divided by 96,500 divided by 2
0.51.
times 40. I have what? 0.51
51.
grams. Analyze. Pwede kayo magtanong. Question? So, saan pa pwedeng i-apply ito? You familiar with dental filling? Anong tawag natin sa Pilipinas yan? Pasta? Pasta
Yes.
ba?
Yes, sir.
Yes, sir.
Parang pagkain ata sa amin dito yung sa US. Pasta.
Spaghetti sa amin, sir.
So yung pag nag-ano ka, yung dental filling, yung magpapapasta ka dyan sa ngipin mo, that is an example of electrolysis. Soldering is also another example of electrolysis. And the one that you're involved here in electrolysis are this one. So usually you use what? Tin and silver. Kung mayaman ka, pwede kang mag-gold. Okay? So I just like to look at the what we call yung self-assessment question. And then I'm going to open the floor for any question for the quiz tomorrow. So I think ito yung self-assessment question nyo, no? Kita nyo ba? So we did number 1 before. We did one of the reaction last time. So ano yung mga self-assessment question nila dito sa last part? Okay, here. So anong sagot natin dyan? Reaction at the anode. Voltaic cell and electrolytic cell. Which redox happen in the anode? They're both what? Parehong oxidation. Hindi ko lang may sulat eh. So whether you have a voltaic cell or electrolytic cell, the reaction at the anode is always oxidation. And if it's an oxidation, what would be the sign? It will be negative. Okay? Now, the reaction at the cathode, usually, that's reduction in both of them, and you will have a positive sign. So if you're going to look at, I think this is a table here. Now, what do you think is the direction of the electron movement? Anyone? So in both voltaic cell and electrolytic cell, it's always alphabetical from A to C, from anode to the cathode. And the difference between the two, in the voltaic cell, the reaction is spontaneous. In electrolytic cell, the reaction is non-spontaneous. And in terms of energy, you produce energy in your voltaic cell, while your electrolytic cell, energy is required, or you use energy. Now, how are we going to answer this one? Arrange the following in increasing order of effectiveness as reducing agent. ALAU copper. So I need to go to the table. That's the only way for you to answer a question like this one. So I want you to remember the aluminum, gold, and copper. So I'm going to share to you here the reduction potential. So you have what? Aluminum, gold, and copper. So you have aluminum. Kailangan ko i-ano. Naka-share ba yung ano, table?
Yes.
So you have aluminum, gold, you have a copper. Nasaan na yung gold? Baka nandito. May gold ba? Wala. Pero meron ako doon sigurado. Here. So you have what? Aluminum. Where is you? Where are you? Aluminum, gold, and copper. No, not that copper. This one. So you have what? 1.50, 0.34, and negative 1.66. So ang tanong, okay, just want to look at the question again. Where are you? Arrange the following in increasing order of effectiveness as reducing agent. Effectiveness as reducing agent. So what does it mean? So if you're going to look at the table here, increasing strength as oxidizing agent going up. And then here, increasing strength as reducing agent. So ano sa tingin nyo ang pinakamalakas na reducing agent? Gold, copper, or aluminum?
Gold po.
Gold? How about the others? Meron nag-ano sa chat ata eh. Gold? So if you're going to look at this, the gold is the one on top. Okay? But isn't it the one it says here, effectiveness as reducing agents? So what does it mean? What usually happen to this, what we call species? Are they going to be oxidized or reduced? If they act as reducing agent, ano yung nangyayari sa kanila? Are they going to be oxidized or reduced? Remember the Leora and the Geroa? So if they are going to be the reducing agent, that means they're going to be oxidized. So if that's the case, you can have it like this, right? Do you follow what I mean? So kapag nag-serve sila as reducing agent, ibig sabihin mag-o-oxidize sila. So kapag mag-o-oxidize sila, paano natin i-arrange dito? Ito ba yung pinakamalakas na reducing agent o ito yung pinakamalakas na reducing agent? Is it the aluminum or the gold? Anyone?
Sir, yung gold po yung mas oxidized.
Pardon? Medyo choppy? Alin sa tingin nyo mangyayari dito? So kapag nagkano yan, pwede natin sabihin the oxidation potential. So every time will be baliktad, di ba? So in terms of what we called here, nandiyan now, increasing strength of reducing agent. So ang pinakamalakas ay yung aluminum. Ang pinakamababa ay yung gold as reducing agent. So ibig sabihin nito, between the three, the one that has the tendency to oxidize is aluminum because they have the lowest reduction potential. And since they tend to be oxidized, that means they are more effective reducing agent. Yun yung interpretation nito. Okay? So, balikan nyo itong recorded na to because I'm just going to stop here for the recorded session because the other session is just like a review session na hindi ko i-record. So question,